Chemical changes. A change in which composition and chemical properties of a substance get changed and one or more new substances are formed is called a chemical change. Some more examples of chemical changes. Explosion of firecrackers is a chemical change. We know such an explosion produces heat, light, sound, and harmful gases that pollute the atmosphere, air pollution. That is why we are advised not to play with firecrackers. Change in color of cut fruits and vegetables on keeping in air is a chemical change. If we cut an apple into slices and keep it in the open for some time, the slice of an apple acquires a brown color due to the formation of new substances by the action of oxygen. Formation of curd from milk. Spoilage of food. Digestion of food. Burning of fuels like wood, coal, kerosene, LPG, petrol. Burning of leaves. Burning of candle wax. Burning of incense stick, agarbatti. Rusting of iron. Photosynthesis in plants. Respiration in living organisms. Characteristics of chemical changes. During a chemical change, one or more new substances are formed. Chemical changes are permanent. Thus, a chemical change cannot be reversed by simple physical methods. During a chemical change, relatively larger amount of heat, light or any other radiation, ultraviolet for example, may be given out or absorbed. During a chemical change, both the physical and chemical properties of the substance are changed. Differences between physical and chemical changes. Parameters: new substance, nature of change, reversibility, physical and chemical properties, amount of energy in the form of heat, light, etc. Physical change: no new substance is formed. It is a temporary change. It is easily reversible by simple physical methods. Only the physical properties of the substance get changed. Very little energy is absorbed or given out. Chemical change: one or more new substances are formed. It is a permanent change. It is irreversible. Both the physical and chemical properties of substance are changed. A very large amount of energy is absorbed or given out. Rusting of iron. Iron objects like iron nails, iron pipes, iron grills, iron railings, etc. when kept in moist air for a few days, gets covered with brown powdery substance called rust. This process is called rusting of iron. The two conditions necessary for the rusting of iron are presence of oxygen of air, presence of water or water vapor, moisture. During the rusting of iron metal combines with the oxygen of air in the presence of water or moisture to form a mixture of iron oxide and iron hydroxide. This mixture of iron oxide and iron hydroxide is called rust. The process of rusting can be represented by the following equation. Iron metal plus oxygen plus water from damp air gives us iron oxide plus iron hydroxide, rust, red-brown in color. Rusting damages iron objects. Rust is soft and porous. The layer of rust so formed falls off from the surface of a rusted iron object, exposing fresh iron metal which starts rusting. This continued rusting makes the iron objects weak and ultimately makes them useless. Iron is the cheapest and most easily available metal. Iron is extensively used in our day-to-day life in making large number of objects such as gates, railings, bridges, grills and bodies of cars, buses, trucks, ships, etc. Rusting causes a great deal of loss and damage. Do you know? There is an iron pillar near the Qutub Minar in Delhi. The pillar is almost 7 meters, 22 feet high, and weighs more than 6,000 kilograms. It was built more than 1600 years ago. The pillar is 98% wrought iron. It has attracted the attention of both scientists and tourists from all parts of the world to accept the highest level of skill achieved by ancient Indian ironsmiths in metal technology as far back as 1600 years ago. Prevention of rusting. Coating the iron surface with oil and grease. Coating with paints. Coating iron with other metals. By converting iron into stainless steel. Crystallization. Seawater contains salts dissolved in it, which make it salty. Salt can be obtained by the evaporation of seawater. This technique of separation is not good because the salt obtained in this manner is not pure and its crystals are small. Also, the shape of the crystals cannot be seen clearly. Crystals are the purest solid form of a substance with a definite geometrical shape. Many substances like sugar, urea, copper sulfate, alum